Hello and welcome back to the development of the Feersum scheme compiler. So let's start by going over what happened in the last stream, and then I'll go over what the plan is for this stream. So in the last stream we did some work on built-in functions. So when we bind, we start off with this root scope, and the root scope is the base of all of the environments. It used to be empty, but we have added additions in it for arithmetic operators, and after the stream I've added comparison operators and a display built in. So each one of these is defined, and that means because it's in the binder we can like at least bind some source code and end up with a bound tree that contains references to these functions. So when you're writing scheme code, these functions can be resolved. And then the second part, and where most of the effort went, was in the actual binding of those functions. So I just search for built-ins. We have this create built-ins, which defines all of our built-in methods. So we've got a bit helper function for actually declaring the method signatures, and then we've got this create arith built-in, which has the IL for looping over the arguments and kind of folding them together in a functional fold with some kind of default value, some kind of nominal opcode, and ends up performing whatever function we're trying to do. We've got a comparison built in, which does a similar thing, but instead of it combining values down using an operator, there's a comparison operator, and it basically loops through and bails out and returns false if it finds a condition that fails. And then the display built-in effectively calls toString on a method and then calls console writeLine on it. So that is close enough to the spec for the scheme display function, but it also means that we can start writing scripts that write things to the output. And then down at the bottom we actually define the map which the compiler will use when people reference a built-in. So when it finds a reference to an identifier and the identifier resolves to a built-in, which we found in the binders map earlier, the compiler will use this map to convert that into a method reference, and then it creates a stub, it creates a system.func and uses that as the value. So when you do something like try and call a plus, that's effectively, if you write plus and then a series of numbers as an application, the way that works in this version of scheme is that first the plus is loaded onto the stack as some kind of value. All of the arguments are evaluated, and then that list of arguments is passed to the value. We try and call it as a function. So we do have to have some kind of object to represent the plus on the stack, which is because functions in scheme are first class, so you could just store plus somewhere else if you wanted to and then call it later or something like that. Right, so where we left off, we were in the middle of trying to make this example from our specs for comments actually work without a bunch of fix me comments in it. So the work from the last stream means that we don't have to define these operators anymore, but there's still a problem of inside the body of this lambda, we don't correctly resolve identifiers. So in this case, n is bound to the parameter, so that's fine. But fact should be this fact outside, but that's in a parent scope, so we can't see that at the moment. We don't actually walk up the scope stack. So that is the plan for today's stream, is to have a look at starting to implement scope stacks properly. But before we get to that, we've got a bug that we need to fix first. So over on the GitHub page, I created an issue for this. Effectively, when if conditions are lowered, we only emit a branch false. We don't actually unbox the value. So this means that every time we evaluate something, we're not actually checking if it is truthy or falsy properly. We're basically just comparing the byte value, sorry, the bits in the reference that we have on the top of the stack, and seeing whether or not they are truthy or falsy according to C#, well, the .NET runtime's interpretation of that. So what we actually need to do is, when we have an object on the top of the stack, we first need to do an isInst check to check if the object is actually an instance of a Boolean, and then we need to try and unbox it and then branch based on the value, because in Scheme, Boolean values are, well, whenever you try and do a Boolean check, so in an if or something like that, values are considered truthy as long as they're not the Boolean value false. So this means that things like the empty list and other kinds of like 0 and things like that that might seem falsy from other languages are considered truthy in Scheme. I'll just try and demonstrate this bug first. So if we get to our REPL, the bug is this. If I type if and then like t for true, and then I do hello and world, the compiler's happy, it gets bound correctly, lowered correctly. .NET is even happy with the IL that we emit, and that appears to have worked. But if I do if with false, we still get the same value, because both true and false are boxed Booleans in this case. So in the IL, we're just comparing the value of the reference itself. And the only way to actually make this if fail is if we go like that and give it the empty list, because in our implementation, the empty list is represented as a null. So all of its bytes are 0, and therefore it appears just like you'd loaded a Boolean 0 onto the stack. So the fix for this should be pretty simple. Let's go have a look where the problem is. So in compile, we've got the lowering of if. So an if expression has a condition. It has an expression to evaluate if the condition is true, and it has an optional expression to evaluate if the expression is false. So we start by recursing into the condition, so that will emit the IL to evaluate the condition, and we'll be left with the condition on the top of the stack. Create a bunch of labels. I'm just going to move these labels to the top first. So we emit the condition, and then here we just emit the BR false. So this will branch to the false label if the value we just computed with the condition expression is falsy. But the value of booleans and things like that, we only deal with boxed values at the moment. So this needs to do a bit more work before it can do that check. So what I'm going to do is, the first thing we want to do, well, the simplest thing we could do is if we just do context.il emit we just use our old friend unbox any, and we want to give it the type we want to unbox into, so that is the Boolean type. What's gone wrong there? Not sure why that's not working. What's gone wrong? Let's have a look where else we do unbox any. Oh, codes, unbox any. Just as double Boolean. Why does it not know what to do there? That one's a type reference, and Boolean. After a good start. Boolean type is an object because oh yes, of course. The squiggly wasn't quite in the right place. We need to do context.assembly. So this first cut won't work in all cases, but it will show that it will at least work with booleans that we had before. So if we do if and then t hello and world, we get hello again. If we do let's just use the scroll back, it's a bit easier, and then with false we get world. So that's good, but what happens if you give it something that isn't a boolean? So anything that isn't false should evaluate to true, but in this case we're getting a null reference exception because the compiler has tried to dereference our empty list. And if we do something else like a number, we get an invalid cast exception because we can't cast the value that's inside the box to the boolean type. So the solution to this is to add an isInst check, which checks that the value is an instance. And to do this, we're going to need to take a copy of the condition. So the way that the C# compiler would lower this is it's kind of similar to if in C# you had written something like if O is false, and then you do something and the C# compiler would lower that to compute what O is and store it in a local, because it knows it needs to do two checks. Because the is false pattern check needs to check two things. First, is the value a boolean? And then if it is a boolean, is it false? So we could do that. We can create like a scratch variable and evaluate the condition and store it into a scratch variable. But for this case, we only need that second value just in this small bound expression if compiler portion. So a simpler option in that case is to use the duplicate instruction to take a copy of it first, then we'll check to see if it is a boolean. If it isn't a boolean, we can jump to our false label. So in this case we will do context il is inst, and we'll check for the same type. And we will so we duplicate it, check if it is an instance. Then what we need to do is, if it isn't an instance, we can branch to the false label. But this still has a slight issue. The problem here is we take a copy here, so we've now got two values on a stack. We do the isInstance check, and then we branch to our false label. In this case, if it was a boolean, we'd unbox the second value and jump to our false label, which means that the values on the stack would be different when you enter the false label. So what I'm going to do is create a new label for when it isn't a boolean. Now we could use a NOP here, but we actually know ahead of time what we're going to do, which is we want to pop the value off the stack. Oh dear. Code has crashed. Reopen. Okay, good. So we already know what we want to do, which is to pop the value off the stack. So we create a pop and we append that down here. And then when we found out that the value wasn't a Boolean, instead of jumping to the false label, we just jump straight to here, pop it, and then we're at the false label. So now we should be able to evaluate Boolean expressions correctly, even if they are not Boolean values. So if you do an if and an empty list, it shouldn't throw an exception because we're not going to get the null reference exception because the isInst check will fail. And if we do the same thing with a value that can't be unboxed to a Boolean, the isInst check will have protected us from that as well. So if we just do if t hello world, oh dear. I've added support for line editing since the last stream as well. So there's a NuGet library that just implements read line, so like GNU read line, like support for reading from the console. It's pretty easy to get set up. So if we do false, we get world, and then if we try it again with something that's not right. We've got that label in the wrong place. So not bool is true. So we need to flip the order here. So in the case, we're going to do a label true. The problem we've got here is that we want to fall through this branch if the thing we want to be jumping to is the truthy thing, because we want to jump in both cases to that, or no, we don't need to flip that. We can just move our not bool up here. So if it isn't a bool, it's truthy. And if it was a bool, we'll fall through. It should still work. Try to work out whether or not that's more jumping, but I don't think it's really any worse. Oh, no, we can't do that, because in this case, I remember why I was thinking we had to do it like this. So if we move the not Boolean check to here, we'd have to jump over that pop to be able to get to the truthy case. So we want the not bool check to be down here, just before the false. We want to have no. We want the not bool to be before the true, because that's where we want to jump to. We want to switch this label round, so we do branch if true to, and then we'll rename this label to true. So if it is true, we'll go to the true label, recurse into if true, and then branch to the end. So we want to take this bunch of code up here and let, if you fall through, so if you fail, effectively it's computing any way that this could be true. So it could be truthy if you're not a bool, and then we jump to the truthy part, and it can be truthy if you, it can be truthy if you are a true bool. So we jump to the truthy part, and then both of those fall through to the end. And in the case that it isn't either of those things, we'll fall through to this falsy stage and then jump through to the end. So we have to do some kind of jump at some point, but I think that's the easiest way around of doing it, because we did a duplicate here and we're using the pop instruction to get that value off the stack before falling into the truthy case. We kind of need to jump to the true case rather than jumping to the false case. Otherwise, we'd have to jump over that pop instruction, and then you have to, it just makes it even more jumpy. So hopefully this should work. Did I ask it to run then? I kind of feel like I did, but I'm not seeing any build. What did I have selected there? Was it unbox any? Opcodes, I think. Yeah. I just saw a load of yellow, orange on the right hand side of my screen. I was trying to work out what I was searching for. If, and then T hello. So if I do the same thing again with a false value, I go to world. If I do the same thing with a value that's truthy because it isn't a boolean and a null value, we still get to the hello. So that's working correctly now. So let's review the changes and commit it, fixing the first bug. So we've changed the label round. So we now have a label for true instead of a label for false. We recurse, and then instead of just doing the branch if false, we do this duplicate, an isn't check, an unbox check. We still do the false case in the same way, and we've moved the true to the bottom because we're wanting to jump to it. That all looks good, and there's no other changes. Properly unboxing values. So references being inspected for the. So the way it works in Scheme is anything's truthy as long as it's not that specific false value, which we're representing as a boxed boolean. I'm just going to amend that as well because right, I can't even type. So I also want to put fixes in here for GitHub so that we get that issue closed. Good. So that's one item to check off the to-do list. The next place to look then is how we look up values. So we've got, let's go back and rewrite that comments extended test, or just copy and paste it and make a new one for factorials. Do we want to do factorials? I mean, we could do something a little bit simpler. Yeah, we'll do the factorial. So let's rewrite this into a slightly more idiomatic form. So when you define a function like fact to be a lambda, you can actually just use the simpler definition form of fact, and then we're just saying, say factorial of n is, and then in the body we're not going to do any of our fix me stuff to redefine any of this. We're just going to do the simple recursive case. So we say if n is equal to 0, return 1, otherwise return n times n minus 1 factorial, which is fact minus n1. Now there's a slightly nicer way to write that to make it tail callable, but not bothering with that for the time being. So we'll do fact display, as soon as we've got it now, fact of 4, because I don't want to spend too much time on it. So if I do that and then run the compiler, it's going to fail because it's going to fail first of all because we haven't actually generated any snapshots for this yet, but it's going to also fail because this doesn't compile. So we should be able to get this to compile quite easily, because when it comes to looking up things in outside scopes, we already look up the n. Okay, so that's fine. That identifier is resolved correctly. We've got the equals and the multiplication and the minus. They're in our globals already, so we just need a way of finding the global values. And then we've got the fact. Now the compiler currently does actually insert the fact. It inserts a definition into the right scope, but we don't have any way of seeing that. So let's go and run this from the command line first. So if we do .NET run, don't need to build it because the test just did. So that has failed, and it fails because reference to an undefined symbol equals. Sounds good. So the first thing we need to do is allow you to see globals from inside. So this isn't actually a problem for the compile section anymore. This is all to do with binding. So when we come to bind an ident, what we do is we call binder context try find binding. So our binder context is this big bag of states that we pass through the bind. So as we're binding methods and calls and all the rest of that, we have this context, just like we have the compilation context that flows through the compile stage. And on our binder context, we have, let's go and actually find we have a bunch of different data. We've got the scope, which is our current environment, and we have the parent binder context. So there's actually two levels of scoping going on here. You've got the stacking of lambdas, and you've got the stacking of scopes inside a lambda. So in Scheme, if I go and have a look at the special forms, you've got let star, let rec, which creates new environments inside the existing lambda. So that allows you to introduce scopes for variables. You could implement let and let rec and all the rest of that as lambdas and treat the lambda environment as the only level of scoping that you have, and do it all with macros. And I think there are some Scheme implementations that do that, but for efficiency's sake, I think we'd rather have like multiple scopes inside a method, just like you would have in C# or F# or whatever. So inside the same method, you can have locals that you can only see from certain parts of the method. When it comes down to IL, that doesn't really exist. You can access a local from anywhere within inside a method, but from the compiler's point of view, we can enforce that. We can say that you're not allowed to load from certain locals at certain points in time by just keeping a stack of scopes. So we've got a scope stack inside our lambda, and we've also got the stack of the lambdas. So each lambda keeps track of what the parent was. So to be able to look up our equals and things like that, we need to be able to walk up the tree and find the root binder context, because the root binder context has those definitions already in its scope. The root context is kind of special in that all of the definitions in the root context are actually globals instead of being locals. That's something else that we haven't yet fixed, is that all variable definitions at the moment are actually lowered as globals, but we'll come to that later. So what we need to do is, when we try and bind an ident, we call try find binding. So what we want is that try find binding looks in the current scope, and if it can get the value, it returns it. If it can't find the value, what do we want it to do? Well, what we could do is we could call try find binding on the parent context with the current ID and return that instead. And then rec. Yes, so we need to deal with the case where there is no root scope. So what we'll do is we will match the parent so if the parent is a scope, we will call try find binding with the parent and the ID. And if there is none, we will return none. Now, is there an ergonomic way of doing that in F#? Because can you do like map or something? That would be option.map maybe. Option.map takes a mapping and an option. So we give it this. A function which takes a parent and calls try find bounding with that parent and the context of parent. Expected type, but has is there a map that deals with this? What I'm looking for here is the equivalent of Rust's and then, I think. Option bind do. Takes an option and turns option T into option U. Evaluates match with none to none and then sum to f of x. Sounds good. That is what we want. Now, if we run this, for our simple case, it should be all we need. I'm just going to cancel this. I don't want to actually run it in the interpreter. I want to run it from the command line. So if I do .NET run, and it was fact.scheme. Really not having a good day when it comes to typing. So now we should be able to .NET spec facts.exe 24. I don't know, is that 4 factorial? Let's go ask Wolf from Mathematica. Four factorial is 24. So that's good. And that does allow references to globals and built-ins from any scope. So I think it's time to run the tests and then check. So these two tests fail at the moment because the we don't have snapshots for them. But if I look at these spec tests, we can just generate some snapshots and then we'll review those. I'm still not quite sure about this snapshot testing. In some of my other compiler projects, when I've had spec tests, I've written things like facts.scheme, and I've had comments that say something like, this should be 24. So I might have a comment that says something like that. And then what I've done is evaluated the, I've compiled them and then run them. And then I've run through the source file with a regular expression. And anytime I saw something that looked like an arrow, I've checked the output of the program to check that it had that literal value in it, which is quite a good way of testing programming languages actually. And it does separate your test suite quite well from the compiler itself. You're not like running the compiler in the same process or anything. But I decided to try and use snapshot testing because it seems like it would have some of the same positives. So that means that our program succeeded, which is good because it's not crashing in any way. We don't want to stage that because that's just turning the spec tests on. And then this is the actual implementation of that second bullet point, which is remarkably simple. So with that, let's stage that and commit it. What is this going to be? Walk up when solving. Binding of so that works for some value of works. The problem we've got with this is that, well, the first problem is, I'm going to add this as another bullet point. When we lower values in scopes, there's this, let's get rid of that to do comment. This to do comment down here, we create a storage ref global for the current ID every time someone adds a binding to a scope, which means that everything that gets defined is a global except for things that are added as an argument binding or things that came in from the original scope. So our built-ins come in when you call create for scope, so they're okay. Arguments come from add argument binding, but calling add binding, this could be called from the global scope, in which case we do want to add a global variable, or it could be coming from a local scope inside a lambda somewhere, arbitrarily nested, in which case we don't actually want a global, because if you define a lambda, let's go and do this and show why it is broken. So if you define a lambda, we're going to call if we define a lambda which has a parameter, it takes one parameter of x. Try to think how you would make this fail. And then that returns a lambda that takes a lambda that takes no parameters and returns x. And you define x to be something. If you define x to be 1, 2, 3, and then no, this is just flat out going to not work because that's capturing a local. I'm struggling to come up with a compelling example of why that's broken, but effectively you expect local variables inside a function to always refer to things in that same function rather than global state. Otherwise, you have it in cases where if you call a function twice, they still see the same value of a variable. Yeah, maybe an example would be if we defined a lambda, had a local variable. Let's do that. So if you define a lambda, let's use define because it's simpler, called a, that has a single local variable called x. Actually doesn't take any parameters. You have a lambda that doesn't take any parameters. It defines a variable called x, but doesn't say what the value is, and then it returns x. But we do that, then we define outside x to be something else, and then we call a. We'd expect this to be the undefined value from inside this lambda here, because you'd expect this x to refer to this, and it does, but that shadows the same like global variable location that this is defined in, because they're both just on the program. And interesting. And then if we return Rx, Rx is now changed. So if I put a display in here, X is initially 1, 2, 3, and then it becomes null. And that shows a couple of issues. One is that the display function does not display null values correctly. Lambda So lambda variables should be locals. But having just said that, I think the first thing to do is to do a bug fix for the display function, because the display function is throwing a null reference exception if you give it the empty list. So in the compiler, we need to change the lowering of display. So the display built-in calls toString. So we load element ref, call vert toString. So we need to do a null check. We can do it up here because we've got the branch to fail. Would we just expect display to so if we got the value here, we will duplicate it. It's the opcode of the day. So if we take a copy of the thing we're supposed to be printing, and then if the value is null, so if we do IL that emit up, actually we could just branch if it's true. I know if branching, if it's true, does the actual printing stuff correctly. So we'll do let. So we have a print. So that should work fine as long as it's truthy, and if it isn't truthy, what we will do is that's a print. We need to do something here. So I think what I'm going to do is just load a string. We load the string, the empty string, and then do that, or duplicate that. that'll make sure that we always convert the value of the display function to a string. In the scheme spec, I don't think the value that display returns is actually specified anywhere, but yeah, the return value of display is unspecified, but for us it's just going to be a string. So if I call display on the empty list, it should write nothing out, right? Operation could destabilize the runtime. I think that is because we want to do we want to load the null and branch if they are EQ. So if it isn't null, convert it. If it is null, use the empty string. I don't think the compiler liked the idea of doing a branch of true based on a reference, which is interesting because that's what the if bug was earlier. Oh, hi. Yes, there is Lisp. I don't know the Scheme language as well as I know other programming languages, but I was taught Scheme at the beginning of university. I have the Principles of Programming Language, or whatever it's called, Structure and Interpretation of Computer Programming, and I'm looking at the Scheme specification itself. So there's this PDF called R7RS. It is on the Scheme programming language website in the standards part. So I'm targeting R7RS small as the language I'm trying to make this implementation as close as possible to. And then when it comes to Lisp, I use Emacs. So I've written a fair amount of Lisp over my time, but an interpreter's cool too. This compiler did start off as an interpreter, and there's still you can actually still run it in the interpreter mode if you want to, but I'm going to strip that out at some point in time, because once I started emitting like IL and things like that, you end up with a case where you've got the bound tree and you have to add support to the interpreter for something and add support to the compiler for it. And then when you're testing it in the REPL, it's not the same as testing it if you compile it and run it. So because this is .NET, and you can just compile to an in-memory assembly and do a bunch of reflection, I can make a REPL that works by effectively compiling, and then you only have one part to test, which is the IL compiler. And also, I'm just kind of interested in the challenge of actually compiling Scheme down to IL and seeing how much of it I can actually do, because an interpreter, it kind of feels more natural place to start for Scheme. But in theory you should be able to compile it because it's got the scopes are all known at compile time. What Lisp have you been using mainly? I think the Lisp that I've used most commonly would be Emacs Lisp. I have a lot of Emacs Lisp. Yep. launched? Oh well. So are we? Oh yeah, I was just trying out the fix for display. Operation could destabilize the runtime. Still not happy. What could be going wrong? I haven't tried Common Lisp. I heard Racket's pretty big and that kind of thing. There's a few others that I've tried, but I've never really had a problem that I've solved using Lisp that isn't like a toy problem or something from a uni course or something like that. Yeah, I think Racket's kind of like partly typed scheme. I mean, if I was going to do anything with it, knowing me, I'd probably write a compiler for a programming language. But we'll see. I don't think it seems like the kind of thing that you'd get very far trying to deploy it to production or something. If you try and deploy a Lisp out somewhere, because it's not really the kind of language that's widely used in the industry. So it's just not necessarily a technical limitation, but it's more of like a cultural thing. I think a lot of it comes down to what kind of languages people are taught, and generally functional programming languages aren't as popular, and so people use things like C# because they're imperative and that kind of thing, because that's the paradigm that people know. Yeah, but there is a lot of inertia with programming languages, so it is a circular argument if you say people don't use this language, therefore we're not going to use it. And with some languages it is possible, like for example the Go programming language grew out of nothing. The same thing with Rust, that's growing out of nothing, but it needs a community behind it. And I think part of the problem with Lisps, and it's also similar in Haskell, is that a lot of the community that is around the language is quite academic, and so it gets seen as being an academic programming language for solving academic things, rather than a real programming language for solving real problems that people want to go and ship in production. But I'm not saying this is my opinion, I'm just saying that's the way it goes. So, compile. What kind of stuff do you contribute to in Common Lisp then? If it's on GitHub, put a link in the chat and I'll have a look at it later. Loading. What's going wrong here? So we load the value out of the array. Then we branch if they're not equal. to the print. So if it isn't null, go to convert, where we call toString. I feel like this sidetrack's gone on for longer than it was initially intended to, and I might just back this out because that can be a bug to fix at a later date. So I'm just going to create a bug for that. Display on the null or the empty list throws and assign me labeled bug. Although if anyone else wants to tackle these kind of things, they are welcome to. Right, so let's not fix that at the moment. And instead, let's work on the Lambda variables should be locals part of captures. So when we define a value, we shouldn't just fabricate this storage. We should ask the scope, like, what storage type. So what we can have is if we change this to be, how many places do we actually use this? So we basically use it when we are creating the global scope. And we call binding context. And we call create with parent create an empty scope. So we kind of want some kind of storage allocation routine. So let's add storage on here, which is going to be well, what is it going to be? It's going to be storage ref global. If we just make that, I want to get the compile error. String to storage ref makes sense. So we give it an ID and it gives us a storage ref. And then down here, when we create this, we need some way of creating local variables. So What we can do is just have a mutable here. And we do storage equals a function that takes an ID, doesn't do anything with it, and it does what's going wrong here? The let block is unfinished. Kind of looks finished to me. I mean, we kind of want the local to be an integer because we want it to be able to be used with load arg, load local. Just don't know what I'm doing wrong here. We'll just make this make this a proper method. Let next local and then next local. What's going wrong here? Can I capture that like that? how do we do mutable values in F#? Why can't I capture that? That's why it doesn't work. And this needs to be storage ref local. That should work. Good. So now let's try and define some lambdas with local values, and hopefully they should have locals. So I'm going to call this as well. Define f. Oh, let's just do lambda. And display. And then we want to give it 4 values. Good. And let's run the spec tests again. So fingers crossed that's not actually changed the way that we evaluate anything. We're just, any case that we've got lambdas, we're now allowing those as references to local variables. Did that just run? It's always concerning when your test suite runs pretty fast. Right. So let's go and have a look at the assembly that generates for one of the example programs. So I'm going to use IL spy on the spec test. We can do it for that fact. Sometimes it's easier to read these from the bottom up. So our main calls the script body, and the script body is here. The script body creates the fact, which is a this delegate. So then we call display on fact of 4. We've got the arithmetic built-ins. There's quite a lot of these now. And we're looking for the actual fact, the actual lambda itself. It's going to be called script body lambda 0. Here we are. So script body lambda 0 has, so what I'm going to do this is IL. I was wondering why I couldn't understand it, and it's because it's reverse engineered C# instead of actual IL. So we have script body lambda 0. Script body lambda 0 is here. We have, this doesn't define any locals. Okay, so that doesn't help us. Let's go and write an example that does. So if we create a new file, we just need to come up with an algorithm that's going to use a local variable. So what we can do we can do fact again, but this time we will do if n is equal to 0, we'll return 1 again. If n isn't equal to 0, then we call begin. In the begin block, we can first compute n minus 1. And then we can return n times fact m. It's just so that we allocate a local variable, and then hopefully we should be able to call that with a value again, and we should get a result. Those tests are failing because we've just written the new one, but we should be able to have a look at the output that's produced by the compiler there. So spec local image is too small. Has our compiler crashed? Probably. So let's try and compile it. project locals. Error code at the end of the input stream. Don't have enough brackets. That's where we're going wrong. When wrapping the define in the right number of brackets. It compiles. Image is still too small. Helps if you give it the exe rather than the scheme source. So we've got our method, we've got our script body, we've got our lambda thunk. This is script body lambda 0, which is going to be fact. There's a lot of stuff in fact. So we've got the arguments to the function. But I don't think we've actually lowered the local properly. This is doing load field program M. So I need to find out why. Oh, because we don't actually call create local here. So we need to have a look at, oh, that's not going well. So this is what I was looking for. So we're getting argument out of range, which is because we create these storage references for a certain local ID, but we don't actually add the local in. So I'm going to say is here, this can be create for global scope. Create with parent scope is going to have a parent and a create local. We're going to do storage factory. Then we will have broken the, so we add an argument binding, create with parent. We need a context. Trying to work out what the best way to map this through to actually. So we bind the body of the lambda. We got the formals. We kind of want to know how many locals there are. So if we start off with the number of locals as being 0. So this is going to be the local index. That's fine. We create the local. Then later on at the bottom, we will actually be able to tell it how many locals the lambda needs. So the lambda is going to be bound formals. It's going to have an int, which is the number of locals it's got, and then the bound expression. And then when we come to lower in the compiler, we're going to need to handle that case. So we'll do emit lambda formals local body formals locals body, and then what happens is we create the lambda, call emit named lambda with the current context. Some scope prefix, formals, locals, and a body. And then emit name lambda can take a formals, locals, and a body. And what it will do is it adds all the formal parameters, and then we kind of want to do a for loop over the up to the local count and add all of the locals. So if they add for 2 for that variable definition type system object. So we want to create basically a local variable that can store any kind of object, because we always use objects. And then we want to add that to the method body.variables. So we add the local and then we're done. Now that might work. Not sure we want to do that. I think try and run the compiler. Nope. Expression was expecting a.b, but has been given. Okay, so this hasn't quite worked. Script body is going to have 0 locals. Deal with that. Admit that's probably a knock-on problem from the body method having the wrong type. While it builds. It compiles and it runs. So let's go back to the test and run the locals test again. That works. What has it generated? So we have the body thunk, lambda 0 thunk, and we have the fact implementation, which has 2 locals. Has 2 locals. Interesting. So we have is this I think this is me doing a bad for each loop, but it's fine. Having a local there and not using it. I only see was as load local 0, store local 0. So that for loop must loop 1 iteration too far. For 0 to locals. So that's going to start off at 0, and then when we allocate it, it's going to be 1. Does that need to be -1? Or is there a way of telling the for loop not to loop that far? Yeah, so it's inclusive, but next local is going to be exclusive. So if we run the compiler again, we'll try running it, the program is generated, and see whether or not we see our factorial. And it was 5, which is 120. Good. So that's working. We're failing because the spec tests are failing because they don't have snapshots. But it's not, what have I got there? That's not what I... Inspector context keys. I wanted task run task please. When your text editor accidentally shows off too much browser. Good, let's review what we've got and look at committing it. So we have the locals version of the factorial, which stage. We've got the change to the lambda, so that bound lambdas now carry the number of locals that they've got. The binder context has the storage factory to generate storage refs, so we don't just generate globals. We generate globals for the global scope. For local scopes, you have to give it a storage factory, which tells it how to generate those pieces of storage. And then we fixed that to do. We've got this new create local, which has a mutable next local. We create our lambda context with that create local, and then when we lower, anyone who tries to allocate in that scope will increment that number of locals, and then at the end, after we've finished binding the body, we pass next local in as the number of locals. Is that off by one? I'm not sure. I'm trying to think about which way around we want that to be. So next local is going to be 0, and then it's going to increment to 1 if we've got 1 local. I mean, we don't actually care in the compiler when we do that for... So we could just do 1 to local count, and also somehow or other we've ended up with a whole load of so we've got our next local. Then in the compiler we've got we match the lambda with the local count and call emit lambda with the local count. Thread that through to the emit named lambda, where we use it to emit some variables for the body IL to reference. And then that's it. We emit the script body with no locals because we know that the script body only references globals. And we've somehow or other picked up some odd compiler errors along the way. We've got the parse for our new spec test, which is a form which defines fact of n, and it does if n equals 0, return 1, otherwise begin, define m as n minus 1, and then return x, so return n times fact m. Good. And then we call fact with 5. Display it. Good. That is correct. And we see that the compiler succeeds for that. And the binary at the end returns exit code 0. So bind lambda body should be method local variables to sounds good. Let's just run the if we run the original test that we did that proved that we were shadowing things badly. So what was that? We defined we defined a lambda called a, which took a variable called, which took no parameters, defined a variable called x to be the empty list. And then we defined our own variable x to be 1, 2, 3. We called display on x. We called a. Then we called display on x again. And previously we were getting 1, 2, 3, and then that was being overwritten to the null value. So what I'm going to do is I'm just going to go display on a, and then we can have this lambda return x. That's not worked. Yes, because we can't call display on a null value yet. There we go. So local variables are working. Yeah. Force pushing because I did an amend earlier. So the next thing to work on is, I'm really tempted to try and fix that display on the null value. So display, the display built in, we get the argument count, and we load the element itself. We need to do some kind of null check here. But how? So in these cases, a good place to go is sharp lab find out what it would do. So what we'd say is if you're given an object and you want to say just if, and you're wanting to turn it into a string, return object, and you want to return x to string. And the way that works is it does load arg, branch if true, so if it's false, it loads null and returns. Let's try and just do the null check one off. Let's do the same thing. So we load argument 0. And what we'll do is, if it is null, we just won't display anything. That's the simplest thing. So we want to just do branch if true. So let's create let so what we'll do is if it doesn't have a value, if we load the empty string, we kind of want a label for print. We're going to use duplicate, so we jump through to the print. So if it's null, we'll use the empty string. If it's not null, we will call toString on it. At least it doesn't throw an exception. That's an advancement. So I will add a spec test for the display stuff. display should be nothing. Should also be nothing. Should be 1, 2, 3. Good. Bug fix null reference exception in display of that when given I know what it was going wrong the last time that I tried to write that fix. Also need to amend that commit to include the GitHub issue. Right. And did I forget to run the test task? I did. So the spec tests are going to fail. Just rerun them and check that they produce something sensible. We get display on an empty string, display on the empty list, display on 1, 2, 3. Sounds good. And the output is 0 because it all succeeds. We're going to revert that because we don't want to include it. And we'll push that. Does our test task work? Looks here. Just got a build failure notification, so I'm confused. Right, so the last thing I wanted to look at today, we're not going to be able to solve this right now, but our approach to try find binding means that if you have a lambda, we will be able to find the value in the current scope, and we'll be able to find it in the parent lambda and the parent's parent, and so on and so forth. And that's fine as long as you're one level deep, and finding your parent lambda means that you find a global variable, or you're any levels deep and you find a built-in function, because both of those are global values. But if you find a local, you'll end up with a bad situation. What I think will happen in our current implementation is you will try and read from the local in the current lambda with the same index as that one. So if we have a lambda which takes two parameters, A and B, and with the two parameters we call another lambda which has two parameters but it's got B and A, and that returns B, so the first parameter to the inner lambda, and we return that from the outer lambda. So we have that lambda and we call it with our parameters A and B. So our parameters are still in the same order, and then we call that with 1 and 2. You'd expect that 1 would be A, and then A would be passed in as the first parameter, so A would be B, and so this would return 1, which means this expression would return 1, which means that the whole expression should return 1, but I think what's going to happen is it will return 2. Nope, it's going to we define a lambda, open, that's the lambda, that's the call to the lambda, that's the inner lambda, outer lambda. Right, why did that work? This is confusing. But essentially what's happening is inside so this is picking the first parameter that's given to this. Ah, yes, because these are arguments. Yes, if you say A, B, X, and this takes B, A, Y, and you return X, that's then going to return instead of it returning the X, which was passed in as the third parameter to the outer lambda, it's going to read the third argument from this one and it's going to return 6. That's the bug. And so what you need to do to solve this problem is that this inner lambda, when it detects that that you're referencing X here and it's not actually in its environment, it needs to go and capture it from the outer environment. So what we'll have to do is have it so that when we walk up the tree and we call try and find binding, instead of just passing this binding straight on, we need to inspect it and see if it's a global or a local. If it's a local, we need to, instead of returning immediately that value, we need to return a bound reference to it. And so what we do there is we'd have the scope effectively take that local variable, and instead of storing it on the stack in its locals array, it would move it into an environment object. So we'd have to heap allocate, and that object that the outer scope has can then be like referenced by the inner scopes. And we have a way of threading that all through. So at the moment, when we lower a lambda in the compiler, and we have emit lambda. In emit lambda, we call method to func with a given method. So method is our thunk reference. What we can do is in emit method to func, we emit load null as the first parameter to this func object array object constructor. So what we can actually do is we can use this pointer that the .NET runtime stores next to the method pointer to store the outer environment, so that we can look up values from the outside environment, and then we can also deal with the case where like a lambda captures a value that's in one level further up. And the way you have to deal with that is by chaining the capture, and effectively each level of lambda captures the outer level's environment and then stores that in its own environment. And then what happens is if the innermost lambda needs to walk up several levels, it basically looks at the environment it was given from the outer lambda, then gets the parent environment from that, and then gets the parent environment from that, and so on and so forth until it's walked up enough, and then it can get the local out of that environment. Right, but that is too complex to tackle right now, so I'm going to wrap up this stream. So thanks for watching, and I will see you next time.